Hello everyone. This is Introduction to Logs for Algebra 2, and the first thing I have to do with you guys is work on being able to pronounce this. You say this: log base A of B is C. So one of the things that I need to work with you on is to be able to say it, but then to understand what it means. So saying it again: log base, this is a base, like this is a base, the x is a base. It's what something is on. So log base A of B is C. And when you go to write it, if this is the line that you're writing on, it's log base A. So it's a subscript. It's below the line of B is C. All that's on the same line, but the A is smaller and lower, like the 2 on an exponent is supposed to be smaller and higher. Okay. So log base A of B is C. That means exactly the same thing. This is translated. These are synonymous with each other. These are synonyms. Is A to the C equals B. So A to the C is B. Now all that's fine and good about being able to pronounce the thing, but what really helps me in understanding what it's saying is A to the C is B, or C is the exponent on A that gives you B. So if I were to write log base 2 of 8 is 3, 2 to the third is 8. This means exactly the same thing. 2 to the third is 8. All right? So being able to say it, log base A of B is C, is one thing, but understanding what it means is completely different. And I want to work with you guys on being able to understand what it means. A to the C is B. Okay. The reason that you want logarithms is, let's say you guys have this. How do you solve it? You square root both sides. Okay, plus or minus shows up. Or if you have x cubed equals 17, you're going to cube root both sides to solve it. Well, what if your exponent is a variable? How do you get rid of that exponent? Well, if you translate it from this format into a logarithm, it will solve for the variable. So this is exactly the same as log base 3 of 17 is x. It's solved for the variable. This wants to know, what's the exponent on 3 that gives you 17? So does this. 3 to what power is 17? That's what this says. 3 to what power is 17? Okay? So that's what logarithms do. They solve for variables in the exponent, because you don't have any other tool to do that. That's what the purpose of a logarithm is to solve for variables and exponents. Okay. Like when you guys have this 25, there's nothing written here. It means exactly the same thing as this. Okay? So when on a root, if something's missing, it's understood there's a number there. On a logarithm, when there's nothing there, it's understood to be a 10. So the base is 10 when the number is missing. And you look on your calculator, you have a log button. There's no base written there, it's base 10. You also have an ln button on your calculator. That means log base E. Now, E is going to be a new number for you guys. E is about 2.7. It's like pi. This number is going to go on forever. It's a non-repeating, non-terminating decimal. All right? So there's two types of logarithms that you'll find on your calculator. This is pronounced natural log. I don't know if it's Latin for logus naturalis or something like that, but it's not written NL for natural log. It's written LN. And I can't explain why. I don't know the history behind why it's written that way. But it's pronounced natural log. This is just said log. Okay? All right. So here, all I'm looking for you guys to do is to translate these suckers. So again, log base A of B is C is exactly the same thing as a to the c equals b. And all I'm looking for you to do, these are in what's called exponential form because they all have exponents. I want you to rewrite them in logarithm form. Just translate it. So the base is 3, so log base 3 of x is 5. This would be log base x of 64 is 3. This would be log, the base is 2, of 7 is x. This would be log base 12 of x is 5. Log base x of 7 is 3. Log base 12 of 3 is x. Now, you can do the intermediate step here when you have e, but then we have to do a final step. So first off, just a direct translation. Log base e of x is 5. And when you guys have a log base e, that's worth the natural log, and then you finish writing it. X equals 5. So you can't leave it log base e. You got to rewrite it as ln. And ln base e doesn't make sense. Okay, that it's already has the base e in it. Okay. So the intermediate step here would be to write log base e of 7 is x. Again, notice all of this is on the same line. The e is smaller and lower. Okay. So then you replace log base e with ln. So that's ln of 7 is x. And I want to reinforce this, you guys. All that stuff is on the same line. The e is the base is a subscript below it. So for example, this, you don't write log 12 to the x is equal to 5. No, this is not right. The 12 is lower and smaller, the x is lower and smaller, this 12 is lower and smaller. And all the rest of it's on the same line. Okay? So here, going to translate them. That's 4 cubed is equal to x. All of these are written as logarithms. I want you to write them in exponential form. I don't need you to solve anything once you do it. Just translate it. X squared is equal to 16. 6 to the x is equal to 7. 4 to the 12th is equal to x. X to the 5th is equal to 7. 4 to the x is equal to 12. You're just translating it is all you're doing. If you want, you can do the intermediate step. I'm going to put the base back in it so you can see it. So that's e to the 8th is equal to x. If you can jump from here to this lower one, that's fine. But if you need to write that intermediate step, no harm, no foul. You're just filling this thing out so to help you see it. So that's e to the x is 4. E to the x is equal to 4. Okay, so that's your assignment, I believe. I don't think that there's another page. Nope. So that's it.